Dear all, welcome to video lecture on CPU scheduling. The CPU scheduling deals with the problem of deciding which of the processes in the ready queue is to be allocated the CPU. This is the common definition for CPU scheduling algorithm. It deals with a problem of which of the process uh, will be kept waiting in the ready queue would go to the CPU first for execution. There are many different CPU scheduling algorithms. The first one is first come, first served scheduling algorithm. Then you have shortest job first scheduling algorithm. Then you have priority scheduling algorithm. And you have round robin scheduling algorithm. In this PPT, we will discuss about first come, first served CPU scheduling algorithm. So this is the simplest CPU scheduling algorithm. In this scheduling algorithm, the process which requests the CPU first will be allocated the CPU first. So that is the definition for first come, first serve scheduling algorithm. The process that requests the CPU first is allocated the CPU first. We'll see an example now. Consider a following set of processes, and here all the processes are arrive at time 0 with the length of the CPU burst given in millisecond. You can see that in this diagram, in this table. Here you can see process. There are three processes. First one is P1, then you have P2, then you have P3. And the corresponding burst times are given 24, 3 and 3. So these are the set of processes. All the processes are arriving at time 0. These processes arrive in the order P1, P2, P3. So first of all, you have to draw a Gantt chart so that you will be able to find out waiting time and turnaround time of these processes easily. So this is how you can draw a Gantt chart. At time is equal to 0, process P1 enters into the CPU first, and the burst time given for process P1 is 24. It executes in CPU for 24 milliseconds of time and it leaves the CPU. Then P2 enters. The burst time of P2 is 3 milliseconds. It is executed in the CPU for 3 milliseconds and it leaves the CPU at 27th millisecond. Then P3 enters. So P3 executes for 3 milliseconds. It leaves the CPU at 30th millisecond. So this is how you can draw the Gantt chart. Now we'll see how to find out the waiting time and the turnaround time for the processes. So here I have put a simple tabular column which shows you the processes and its burst time along with waiting time and the turnaround time. So by looking at the Gantt chart, you can able to see how long a particular process waits in the queue before gets into the CPU for execution. So when you take process P1 does not wait at all. It enters into the CPU immediately once it arrives in the ready queue. So the waiting time for process P1 is 0. And process P1 leaves the CPU at 24th millisecond, and now the next process which are kept waiting in the queue is P2. Now the P2 enters. So P2 has waited in the ready queue for 24 milliseconds of time. Then you can consider P3. So P3 enters into the CPU at a 27th millisecond of time. So we kept the waiting time for P3 as 27. Okay, now we'll see how to find out the total waiting time and the average waiting time. So as it is given here, so when you sum up the waiting time of the processes, we will get 51 milliseconds. And when you find the average waiting time, that is 51 divided by 3, you will get 17 milliseconds. Now we'll see how to find out the turnaround time for each and every processes and then we'll see the total turnaround time and the average turnaround time. Turnaround time calculation it is simply waiting time plus burst time. So waiting time for P1 is 0 and burst time is 24. So when you sum up, you will get 24 as the burst waiting as the turnaround time for process P1. For process P2, the turnaround time is 27. That is 3 plus 24, we get 27. And for P3, it is 27 plus 3, 30. So when you sum up all, you will get total turnaround time, that is 81 milliseconds. And to find out the average turnaround time, 81 by total number of processes, that is 81 by 3, you will be getting 27 milliseconds. Thank you all.